you very much for inviting me to this very interesting conference here in Berlin. My son, my oldest son, in fact, is working here in Berlin in the Deutschen Bundestag, and he is concerned with traffic in Berlin, so I know much about that, what is happening here. I myself come from Duisburg, that is at the one corner of the Ruhr area. We are place 26 in the ranking of the metropolises around the world, and the problems we have there are at other places, maybe in some years, but we know what we are talking about. So this professorship in theoretical physics, I'm a theoretical physicist, was built by my own. So it's the one professorship in the world where a physicist is concerned directly with traffic problems. So the problem is that the people want to move. So if you're sitting here for, say, 1.5 hours, you get restless legs and you want to stand up and go around. And that is a phenomenon all over the world. And in fact, there are several possibilities for you to move. So you can walk, then it is timely in following horse riding, carriage riding, bicycling, train riding, and so on. So what you are doing now is, you saw that before, that you try to fly by your own, and since space is limited, you think about a third dimension. So the prophecies of the future mobility are very old. So you see here something, a forecast from 1925 to 1950, and you see all means of traffic were separated on separate floors, and you know that today it works completely different. You see Frans Mazereel, a Belgian artist, already showed that the city should like it is nowadays. It's from the same date, 1925. You see all the cars together, shared space, we call it today. And that was the situation in Berlin, 1925. You see there, by the way, the first traffic light in Germany in the middle of the picture. And you see this also looks like shared space. Cars, trams, and pedestrians together on the same road. So why the people move? The people move to get food, money. They go to work, they go to care, health, learning, culture, sports, fun. So if you're a tourist, you have a way of care, health, and on fun and sports. So the combination of all these is common. So what is then at the end the possibility? We can move physically from A to B, or we communicate via media as we do it in times of home office. But in the end, maybe we have a combination of both. Teleportation, Professor Steilinger from Vienna also made this in physics. So maybe like Star Trek, we are beaming up in the future and nobody has to move physically, but that is a far future. We had to look in the brain of the drivers or the people moving, and with fMRTs, that is functional magnetic resonance imaging, and we looked into the brain of a driver. Okay, that's too fast. You see in the middle of the figure here, this is the red point, the small red point, upper left, is the great brain. And what you see is that people moving, especially drivers, are not thinking about what they are doing. You see the other spots are the audiovisual cortex or the sensomotoric vertex, which is active, but not the great brain. People move without thinking. They are thinking about several things, but not what they are doing at the moment. You see, especially today, distraction is very common. Go through Berlin and you see many, many people just watching at their smartphones. You see that is Stockholm. You see there are traffic signs, especially that was from an artist. It's not an official sign. Okay, there are several projects around the world, say, separating these kinds of traffic. That is special smartphone lanes. There are 3 projects around the world, but they are stopped now since tourists came and made photographs of that special lanes. They were only interested in that. So, you see, there are many, many mathematical theories. I made them also 30 years ago. We started to understand human behavior and traffic. You heard already that these driver behavior models we made several years ago. We are now also working on autonomous vehicles. And you see the traffic jam scenario is very, very rich. The structures you see here that are jams, and you see also that this is only known since, say, 30 years. 30 years ago, we made a theory to understand this is the first simulation where we simulated a jam out of the blue. It is the so-called Schreckenberg model, which is now common all over the world. It's rule-based. It is not a complicated mathematical theory. It's very, very simple. Also, young people can understand it, but you can simulate very complicated structures. So the problem is also that people react in a different way, as you mean, or as you expect. Say, if you gave traffic information to the people, maybe they don't go there where you mean they go, and the jam will not occur. That is the self-destroying prophecy. So you tell the people what you expect, and it will not happen since you told it to the people. They make something different. So we have different levels, strategic and tactical level, where the people act. Strategic is where you go along, and tactical is that you are working or moving on the rules in that system you use. You see, autonomous vehicles, so everything you can do something against it. You see here the trap for an autonomous vehicle. It will never move again. If it's driving into this trap, it will never come out. So there are several problems we also heard about. It is made by salt. If you have a car in front of your house and it's you want to trap it, just take some salt around it and it will never move away. So there are other ways of traffic in the future. Ropeways that pass Bolivia, you always heard about that. Or you have already seen this Volocopter, that is an air taxi in Germany. It was presented, but it didn't fly. So maybe in the future we will have some of them here in Berlin. You see the Hyperloop, he has very, very great speed, about 1,200 kilometers per hour, 1 hour from Paris to Berlin. That would be an interesting future for fast earth-bounded traffic. You see also here the drones. We heard about that from this vision van from Daimler, where these drones can take up to 2 kilograms and they can fly up to 10 kilometers and come back. Maybe this is an option for the future, but the legislative doesn't answer all the questions which occur with that. Maybe this is what you mean when you think about chaos, but I don't mean this. You see that it is from India somewhere. I don't know where exactly, but you see that is not the chaos I mean. So chaos in physics, or the goals of mobility, are very unclear. You see low environmental impact. It must be realizable what you want. Low costs, simpler processes. It must be acceptable by the people. It should improve traffic flow and give less jams. You heard about that. But at the same time, you have less space for traffic. And at the end, what is better life? What do the people want? And theoretical physics, you understand, with chaos, strong dependence on the initial conditions, exponential drifting apart from the resulting states. You heard much about exponential expansion, and you have highly nonlinear processes. Nobody knows what the result will be, and it's not stochastic, it's just deterministic evolution. And it's completely different scenarios can occur. At the end, the initial data, you don't know really. Readjustment is very complicated. You see that at the Berlin airport. Yeah, who will readjust? That's what happens there. And at the end, the conclusions are: is this evolution technical or human-driven, or the scenarios we have, i.e., local solutions which are not portable, not general solutions are possible. Energy, climate resources, you can read that. Younger people think completely different. We heard about that. And the long-term predictions are impossible.